To start, go ahead and copy down this warm-up here, these like little 4 problems. I'll wait. Now that you've copied them, let's actually do these. What I want you guys to do is calculate what these are without a calculator. So by letter A, we're going to follow the order of operations and just do the exponent parts first. I know that 2 to the 3rd power is 8, and 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 32. And if I do 8 times 32, I'm going to get the number, let's see, that'd be 256. You can do that off to the side, just kind of a little easily remember your algorithms for multiplying. But anyway, 2 to the 8th, well, that's the same thing as 2 times 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 2. Okay, 8 times. And this should be the same thing as what we saw with that, and this should be the same thing as what we saw with that. It's the same thing. So if I look at the next one, and I'm just going to kind of expand this out, I have 3 to the 2nd power is really 3 times 3, and 3 to the 3rd power is really 3 times 3 times 3 times 3. That's the same thing as this. 5 3s. And the rule, the rule that you guys should come up with, so inevitably what we have is that this is really 3 times 3 times, I mean, these are the same thing. And by the way, that would be the same thing as 324. Or sorry, not 324, 243. But I care less that you know that these are the same and these are the same numbers as I know that they're the same right here. What I mean is that kind of the generality is if I have something like x to the 3rd times x to the 5th, that's the same thing as x to the 3 plus 5, or x to the 8th, which is what we're going to see down here. If I sort of take these examples and group together ones that have the same base, like this and this, what I can start to do is kind of pool them together and say that this is really 3 to the 3rd power times 3 to the 2nd power, and this is really 2 to the 3rd power times 2 to the 1st power. This is sort of like grouping like terms, but I don't want to call them like terms. We're going to actually call them common bases, because we're going to use that word base that we did yesterday, actually in class. So 3 to the 3rd power, actually today, because this is when I'm recording this. This is the day that we should have had off for school. And tomorrow, we have to go to school again. Sweet. 3 to the 3rd, 3 to the 2nd, this is going to be 3 to the 3 plus 2. And this is going to be 2 to the 3 plus 1. Or 3 to the 5th and 2 to the 4th. You could go straight from here to here, but really when it lumps together, I want you to understand that what this really is 3 times 3 times 3 times 3 times 3 times 2 times 2 times 2 times another 2. And that's where you get your 3 to the 5th power, and this is where you get your 2 to the 4th power that we see right there. That's a lot of arrows. Number 2, when you have variables, you're like, wait a minute, don't we want a number? Nah, not really. Not right now. I don't really care about a number. Yeah, you could do it, but I'll let you do that if you really want to. Number 2, here we definitely don't have a number because I have all variables. Y to the 4th times y to the 2nd. This is going to be really y to the 4 plus 1 plus 2, all as an exponent. Because if I multiply the bases, I'm going to add my exponents. Get y to the 7th, and that's the simplified version. So up to the side here, I'm going to say multiply bases means add exponents. For number 3, it doesn't matter how these are organized. Remember, we have this associative property and a commutative property of multiplication. So really, I'm going to put this together as m times m squared, then times n squared times n, and put these things kind of together so I can see, okay, that's really what's going on. M times m squared is m to the 3rd power, and n times n squared is n to the 3rd power. That's the simplified version. These parentheses didn't matter because multiplication does not depend on where the parentheses are. This is all the same thing. 2 times 2 times 6, 2 times 2 times 6, 2 times 2 times 6, doesn't matter. So I want you to kind of keep that off to the mind, that don't let those parentheses mess you up. In fact, over here, number 4, it's easier to multiply the 4 and the negative 5, and then the n cubed and the n squared to get us n to the 3 plus 2, or n to the 5th. Notice how I'm skipping right away to the end. Number 5, if I just take it slow, I can group the negative 7 and the 3 to get negative 21. I can take the x squared and the x to the 4th to get x to the 2 plus 4, or x to the 6th, and then y cubed and y to get y to the positive 4. Number 6, well, I have 12 fifths and 10 thirds, and I can really multiply these two together and do some canceling. Remember, that's really division, so don't let that mess you up. 1 and 4, and 1 and 2, and 4 times 2 is 8. Then take my a to the 3rd and a to the 4th, and that's really a to the 7th. And take a b and a b, and that's really a b to the 2nd power. Okay, let's flip it to the back, next page. 20 times 12 is 240. X to the 2nd times x to the 3rd is x to the 5th. And y to the 1st times y to the 5th is y to the 6th. Very common mistake is for people to take that x to the 2nd and x to the 3rd and make that x to the 6th. But remember, multiply base means add exponent. Add the exponents. And that can only happen when you have the same base. Number 8, if I do 2 times negative 8, I get negative 16. Then x times x to the 4th, x to the positive 5, and then I'm going to have y to the positive 4th. Over here, check my coefficients first. So this is a 1, and that's a 7. It's positive, so it's a plus 7. X to the 2nd and x to the 3rd is x to the 5th, and y times y to the 3rd is y to the 4th. Now you're going to notice something about these two. These are actually now like terms. Remember from yesterday that like terms are the same variables. They both have x's and y's to the same exponents. The x is to the 5th, the y is to the 4th, and when I add like terms, I just add their coefficients. Negative 16 plus 7 is negative 9, so that's going to give me a negative 9 x to the 5th, y to the 4th. Can make this a little bit more complicated. Looking over here, I got, well, 4 times negative 5. I'm just going to take it step by step. 4 times negative 5 is negative 20. A to the 5th times a is a to the 6th. B times b to the 3rd is b to the 4th. And c times c to the 3rd is c to the 4th. Now over here, negative 2 times 3 is negative 6. A to the 6th. B to the 4th, there's no b on the right side, so it's just b to the 4th, and then c to the 4th. These are also like terms. Negative 20 minus 6 is negative 26, a to the 6th, b to the 4th, c to the 4th. Number 10, whoa, we're going to go back to that same rule. If they have the same base, that means when we multiply bases means add exponents. Multiply bases means that you add the exponents. So I'm going to multiply the bases. I'm just going to stick an x in there, and I'm going to add the exponents. R plus s, and then plus that invisible 1 that's sitting there. And that's it. That's as simplified as that thing goes. R s, or x to the r plus s plus 1. Later on in Algebra 2, you'll start to see what happens when we have variables in the exponent, like you can see now. Let's go to number 11. Here I can do the same thing. I can multiply the bases and add the exponents. 3 plus x minus 3. The 3 minus 3 cancels, and I just get 5 to the x. Number 12, my base is a negative 3. I'm going to keep that with a kind of parentheses there. My exponents, I'm going to add 1 plus x minus 2. So I have negative 3 to the, this would be x minus 1, because 1 minus 2 is negative 1. And we're just going to leave it like that, quite honestly. No reason not to. 13, we're just going to multiply the bases, means we add the exponents. So I don't make 2 times 2 is 4. No, 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 no. They have the same base. which means that when we multiply the bases, all we do is we add the exponents. We don't change the base. Multiply base means add exponent. Do not change the base. So add the exponents, x minus 3 plus x minus 4. Oh, sorry, plus x plus 4, which is 2. So the x plus x is 2x, and then negative 3 plus 4 is positive 1. That's it. Now, you might be thinking, well, wait a minute, didn't we just multiply things like this? Yeah, but these now aren't bases. Remember, those two are coefficients, so we can multiply coefficients just fine. 2 to the first times 2 to the first is 4 to the first, so that's okay. Okay, number 14. Find 3 consecutive integers whose sum is the square of 6. Consecutive integers, remember we have that pattern, let x equal the first consecutive integer. Sorry, still getting used to writing. Let x plus 1 equal the second. I guess I don't really need let there. And then x plus 2 equal the third consecutive integer. And the sum would just be adding them all up, so x plus 1 plus x plus 2 equals the square of 6 is 6 squared. So 3x plus 3 is equal to 36, or 3x is equal to 33, or x is equal to 11. And I can say the numbers are 11, 12, and 13. Find 2 consecutive odd integers whose sum is the cube of 4. Okay, so consecutive odd integers. We're going to let x equal the first, COI. And don't forget, I had you guys write last semester that consecutive odds follow the same pattern, same exact pattern as evens. They're the same pattern as the evens. So what that means is that x plus 2 will be my second COI. And it says whose sum, so x plus 2, means equals. Cube is a power of 3, 4 to the third power. So I have 2x plus 2 is equal to, and 4 to the third power is 4 times 4 times 4, or 64. 2x is equal to 62, and x is equal to 31. And I could say the numbers are 31, and plug 31 back in right there, 33. Then we have 4 consecutive integers. So let x equal the first CI, and set up your x plus 1. Sorry, they're consecutive, they're not consecutive even. X plus 2, x plus 3. Okay, done. And the sum of the two greatest, so that would be the x plus 2 plus x plus 3, means equals. 17 less than is negative 17, kicked off to the right. Twice, 2 times, the sum of the smallest. And that'd be the x plus 1. There's my equation, no exponents here, but let's simplify the left and simplify the right. 2x plus 5, 2 times 2x plus 1 minus 17, or 2x plus 5, and that would be 4x plus 2 minus 17. 2x plus 5, 4x minus 15. Subtract 4x, and I get negative 2x. Oh, I'll show that. Actually, let's subtract the other way. Let's make this negative 2x. That's positive 2x. I'm going to add 15 to both sides. And then I'll divide by a 2. And so I get 10 is equal to x. And then I get to say the numbers are 10, 11, 12, and 13. Lastly, we have 4 consecutive odd numbers. So we're going to go let x equal the first COI. Then I have x plus 2, x plus 4, and x plus 6 for the second, third, and the fourth. Sum of the two greatest, x plus 4 plus x plus 6, is 4 times, and the smallest is just the x. Add the left. 2x plus 10 is equal to 4x. Subtract 2x. 10 is equal to 2x, which means that 5 is equal to x. And I can say the numbers are 5, 7, oops, forgot my 5, 5, 7, 9, 11. Done.